What's good, everyone? Another SageMaker video today, and what we're going to be visiting specifically is a feature we've seen before if you've kind of followed along with the series, and that's the Large Model Inference container. I'll link down below kind of the introductory video to this, but what I want to do is, this is not a container that just stays static. There's updates over time, and as we know, this LLM space is continuing to evolve in many ways, and so is hosting these models in an efficient way for inference. And along with that, this container will also evolve within AWS to kind of serve those latest kind of technologies that you might have accessible for yourself and make it as easy as possible, right, to get started with hosting an LLM, be it on SageMaker or any other kind of like hardware service of your choice that you want to work with. Obviously, today we'll explore its kind of native and tight integration with SageMaker, which is a managed ML service, right? But you can take this on EKS, EC2, wherever you want to play with it too if you want as well. But what we'll do here, right, is we'll quickly revisit what LMI is for those of you that might be new to this. I suggest watching the introductory video if you don't have any kind of background. I'll link that down below once again. But we'll revisit it, what exactly it does, what does it expose, and why is it so beneficial for hosting LLMs in an easy way. And then we'll talk about what's new specifically in the V16 container. There's been quite a few versions of this over the past few years. And kind of as we launch new containers, I want to document them and explain what's changed, what's new, because we know the space is changing a lot, so we want to stay up to date with that. And then finally, as always, we'll get hands-on. Don't just want to talk about this theoretically. We'll walk through a Qwen 3 model. I used a smaller instance because I don't want to get build weight too much, or a smaller model because I don't want to get build weight too much here. But we'll take a Qwen 3 open source model, and then we'll deploy it on a SageMaker real-time endpoint using it with this V16 container. But let's get right into it. So in terms of the LMI, which is Large Model Inference once again, container, essentially what this is that it's a model serving engine that also exposes different LLM serving technologies as options for you to host. So at its brains, there's a DJL, Deep Java Library Serving Engine, built by AWS that is kind of powering this itself. That's the actual server that is powering this entire engine essentially. But what this DJL serving engine does is that it also exposes different backends. So there's a lot of popular LLM serving frameworks, right, that are out there. And the popular one we'll talk about today is vLLM. Other ones include like NVIDIA's TensorRT LLM. And via each of these, right, there's a number of different optimizations that are exposed related to KV caching, related to batching, kind of the latest and greatest kind of science, kind of advancements in this space in terms of being able to more efficiently host these LLMs are exposed via these different serving engines. And what the LMI container does is, on top of this DJL serving stack, it exposes these backends as configuration options for you. So the knowledge that you kind of need to have before coming here, or as an ML engineer that you might want to acquire in this space, is understanding these different serving engines. The V16 container standardizes more on the LLM itself. So that's the one I'd say if you're going to use this container to kind of go forward with, at least in terms of support always being latest and greatest there. But essentially, you can kind of understand these serving stacks, get a better look at what are the different optimizations there are that might specifically help for your model itself, and then kind of benchmark and profile this, right? We've talked about load testing before. It's also neat to try to kind of test different kind of serving engines and see which one is more apt for your use case. I wouldn't say there's one answer for every kind of problem or one set solution that's better, because with LLMs, as we know, there's a wide range of use cases, right? So depending on the use case, depending on your domain and your specific model, you maybe want to profile and benchmark multiple of these and kind of get a better understanding. But at least for V16 for LMI, there's standardization on vLLM at the moment, because that's also the serving engine behind multi-adapter inference, which we'll get to in a second. But yeah, essentially you can pick one of these backends and you can configure a bit of a servings dictionary or file basically. And in this, you define these different optimizations depending on the engine you use. So you can specify here for engine, you can assume this is something like vLLM or MPI, which represents the TRT LLM. And then you can have the different serving properties here. So if you're using vLLM, there's the async engine, for example. You can set that to true and basically kind of iterate and go through this. And we'll also look at the different user guides for these different backends. So if you're really new to this space, you can see what all these different properties mean. There's different things like max model length, things of that sort that you might want to play with depending, once again, on your use case. So that at a high level is Large Model Inference container. You can think of it as a very easy way to kind of get a managed vLLM container exposed through the DJL serving engine, basically. and same for Tensor RTLLM. And in previous iterations, which are no longer supported, there's also Deep Speed and a few other model, I think Accelerate as well, that are also different kind of LLM specific serving frameworks that existed. Now within V16 specifically, what's new is there is the latest vLLM version supported. Forget the exact one. There's so many versions at this point that I'm blanking on. 0.10.2. But there's a later version too, right? You can take this base container that's given and also install the later one on top of it. So this will iterate pretty quickly to keep up with the open source, these managed containers. But you can always go that BYOC route, right, that we talked about, where you can take a base existing AWS managed container and install the necessary dependencies or any upgrades that you need on top of it. And same goes for TRTLM, right? Even though it's not being as actively supported anymore in these later versions, if you ever need to use TRTLM on SageMaker, all you do is you bring your own container, use that managed TRTLM container that does exist for the latest version, and then what you can do is install the necessary versions, pin those, and expose the SageMaker contracts. And if we remember within that, there's port 8080, which must be exposed, and your web server must be listening on dash invocations and dash ping for the help check for model inference. So you can pretty easily customize to if there's ever kind of any use cases where you have to expand upon this or install further. So V16, the latest vLLM support comes. There's also new custom input and output formatters. And this is especially useful, right? If you have any kind of customized pre-processing or model loading that you want to do, there's simply a decorator now that you can attach basically and say, hey, this is my model loading code or pre-processing code that I have, and this is how I want my output structured. So there's decorators now that that you can simply apply. And before this was a little more nuanced or complicated because especially if you had rolling batch, addressing each item in the batch kind of was a little more difficult, but they've standardized now on this decorator format, which will make it a little simpler for you. Along with that, we already had a video around this, so we already kind of used this. There's multi-adapter inference support via vLLM. I'm not sure if TRTLM has support, but at least from my understanding of this container, we have vLLM's multi-adapter support as the one that's enabled. But I honestly haven't used the TRTLM engine too much for me to know there. But like I said, you can kind of adapt and customize this as you want. So there's multi-adapter inference support via vLLM's asynchronous engine. So async engine is what vLLM recommends as the default by now, especially as you're dealing with more kind of concurrent requests or things of that sort. They've built this async engine as a solution, and now multi-adapter inference support is also kind of natively integrated with it. I'll link down below, once again, the vLLM async engine implementation. You can take a deeper look if you're interested in terms of how it's been formulated. But this is recommended as kind of the standard, both by the LMI containers and as the vLLM engine itself when you're using this. And then along with this, right, there's, I think the third thing that's also here is sticky session routing. So in the case, right, that you're in the same session, let's say like you have one session where you're interfacing with the chatbot, all requests will get routed to the same instance for where that session has been conducted. This way, for existing knowledge and things of that sort, right? This makes it, well, this optimizes the latency there. You can imagine if your previous answer in the same session was routed to one instance and the next question is routed to another instance, that's going to add some latency there, right? When you route it to the same instance there itself, then you can have that existing knowledge there already, and you can iterate quicker basically at a high level. I know I'm like kind of simplifying that there, but in essence, you're routing to the same instance as long as you're on that same session, which will then optimize for latency, right? And you can think of it intuitively, where if you have your existing question or your existing conversation within that session on a different instance, and your next question in that same session gets routed elsewhere, you can imagine there's going to be a bit of a latency hop there that's added. So this is very important, right, for kind of stateful applications where you want to retain that, especially with LLMs where you have things like chatbots. This is a very useful feature that you want to think of, and we'll have a specific sample around this and how you can enable it as well. But this is now enabled by the LMI container. When it was first launched in AWS, it was supported on TorchServe, but now you have this feature via the LMI container as well. So yeah, that at a high level is what was new within this. There's code samples for each of these three. We'll probably build their own videos around them, but what we can also, and we already have one for multi-adapter, like I was saying, but we'll kind of address those and build realistic use cases and then bring those videos. But in the meantime, for today, what I want to do is just get started with working with this container. For those of you that are new, or those of you that are already using this, we can see specifically, right, in terms of how we can use this. Where does it differ maybe from previous versions? But With that being said, let's just get right into it. So here I'm in my familiar AWS console on the SageMaker AI panel. I feel like I've spent my entire life here. But if you come here, right, you can open up a studio environment or notebooks. Studio is where you can visualize inference component-based deployments. We're going to be using that today. And once again, I keep referring to the videos in this series. I really recommend you watch some of them because these kind of make sense as building blocks on top of each other. With inference components, basically, I'll explain this a little more as we go through the notebook. You can delineate resources per container or per model, right? And that's useful with LLMs. But back to the point, you can start a Studio Lab environment or you can use a classic notebook instance. I'm in a classic notebook instance right here, and I've cloned this sample repository. This is the official AWS samples one. I'd say this has probably some more of the latest and greatest kind of examples, and a lot of my colleagues also push here and stuff. So you can kind of take a look at all of this to see different model support, different features that exist within SageMaker Inference. And specifically, we will have a section. I just created this folder for different container launches. So as new things come, you can kind of see the new features here. We'll be using this notebook where we'll use LMI v16 as a kind of introductory notebook here, and we'll obviously build upon this with more samples. But if you come to this notebook, right, like I said, there's a few other features that you also want to think about. I've linked kind of the initial documentation around it if you just want to get started with it. We'll build more sophisticated samples around them, but you can take a look at how each of these work and how you can enable these. And you can also see it's very, very intuitive and simple because these are just kind of flags that we're enabling within those serving files. But to get started, if we come here, right, we need a Hugging Face access token once again, just to access the model artifacts. We'll be using a Qwen3 based model. And like I said, check out the other samples in this repo. A lot of my code is just from other examples here as well. And we just adjust it for our own use case and for our model. But here I set this up. I install SageMaker in Boto 3. SageMaker is a higher level Python SDK that kind of wraps around Boto 3, which is the lower level AWS Python SDK, which has utilities to work with any AWS service. I set up my S3 bucket. I set up a session to work with SageMaker in. I set up my usual clients, the usual tools that we use to work with SageMaker. And then here, right, this is where the real magic kind of happens. We're going to be working with a Qwen3 170 model. This will require a much smaller instance, which I did on purpose. Didn't want to build up too much here. But if we see here, right, I've selected my instance type as a G5-4X large for my hardware. This has one GPU. You want to be really aware in terms of the memory that your LLM will require. Because remember, it's not just the model data, there's also the KV cache size. And then if you think about your max model length in terms of your input and output that you're generating, that also impacts KV cache calculations, right? So you want to do some back of the napkin math there in terms of understanding it. But for this use case, at least, especially since it's just a prototype, I went with the G5-4XL, which was enough to host this. And we only need one GPU. So the container, right, you can specify this LMI16 string right here, and you can adjust this variable basically depending on the region you're in. I'm going to use east1, but once again, we're just going to be using that DGL inference image, and we're going to be pointing to LMI v16. And now really the meat of everything we're working with is going to be here. So we have our Hugging Face model ID that I'm working with, which is the Qwen model. You can also point towards S3 model data if you have a fine-tuned artifact off one of these architectures in a S3 bucket. And then I specify my Hugging Face token. I don't know why I keep putting these here. I'm going to delete this as always. But if we come down here, right, we enable a few different things. We set the async mode to true. And async mode has its own version of kind of batching enabled as well within vLLM. And then here we also set TP, tensor parallel degree, for the number of GPUs that we want to work with. And most importantly, this entry point, right, this is the engine that we're specifying basically. I probably should have put this up top there. But with this engine, we're going to specify we're using the vLLM async service, right? So this is a standard that you want to use from this container version and on. And here we say trust remote code. This is because we're pulling directly from the Hugging Face model repository. We build this out, and then this is basically our serving stack. And like I said, there's many different parameters that you can also tune here. DGL docs also have vLLM kind of serving guide right here for the different parameters that are available for you. So you can kind of play with those. Different things include like max model length, KV cache utilization. So as you're running your load test, maybe you want to play with different kind of parameters for all these different values and kind of conduct iterative tests through that to really understand for your use case what makes most sense. But for the sake of this, at least we go pretty minimal here. We walk through this, and then we do the actual SageMaker part, and you'll see it literally just takes a few cells or a few lines of code here. What we'll do is we'll use the higher level SageMaker Python SDK. In previous videos, I used Boto 3, which has a little more verbose API calls. This simplifies it a little more. And what I'm going to do is I'll define my model, endpoint, and IC objects. These are the same SageMaker inference constructs we have. For my model object, I don't have any model data, right? Because this serving dictionary itself will pull the model data down for me into the instance's memories. So I specify my LLM v16 image. This is my environment file, which is also pointing towards my model data. Specify my model name. Now that I have that right, I can deploy it. My initial instance count is just one. I don't have a big scaling use case here, but obviously you can enable auto scaling as you kind of escalate this in terms of the traffic that you might be facing or things of that sort in a real world setting. I set my container startup health check timeout to 10 minutes. This is important because remember that container needs to be able to pull down those model artifacts into your hardware's memory, basically. So the larger the model gets, you might want to increase this parameter here. And then we specify endpoint name, and then we say that we're going to create an inference component. Once again, the difference with an inference component from just a traditional SageMaker endpoint is that you can specify the hardware that each of these containers need. And basically, the idea behind this is right. You can have multiple components on a single endpoint. Let's say we have an 8 GPU instance backing our endpoint, and let's say just for a hypothetical, right? This model actually required 4 accelerators to be able to host it. Let's say we have a llama model that required 4, and we needed both on a single endpoint. You can imagine this becomes pretty powerful then, where you can basically allocate compute, and then you can also, we don't do it here, enable a scaling policy for each container depending on the resources you've allocated here. So one copy of this model or container preserves a singular GPU behind your endpoint at all times and this amount of memory. Once again, like I said, you have to check your instance memory and compute that it has and kind of do some math in terms of what do I actually need to host this, and especially as I scale it. You can imagine, let's say at 10 and this is just a completely made up number, let's say at 100 requests per second, that you know that this GPU gets saturated here, right? Then you might want to scale out at 80 or 90 to have 2 copies of this model where there's 2 GPUs reserved to be able to handle that traffic, basically. So you can see end to end, basically, right, how this becomes very, very powerful when we're dealing with multiple LLMs, which is pretty realistic in a real world use case, and you need to enable scaling on a per component basis. And like I said, I'll link the inference component video down below once again. Just a great, efficient way of kind of hosting multiple LLMs. So take a deeper look at that. And that's why you'll see there's 2 exclamation marks here. The first one means the endpoint created, but there's actually nothing behind it. The component that gets created with these resources allocated. And we can see that in the Studio UI, if you come down to endpoints right here, I think I need to refresh this. Let me maybe open this up again. You can come here to Studio, and then you can open Studio right here. If you have a domain, a free domain, you don't need to have a Jupyter Lab space or anything of that sort. You can just visualize this. If we come down here, we'll see deployments, we'll see endpoints. You'll see our created endpoint right here. But really the meat of what we did here was this IC model that we created, this inference component. And you can see there's 1 GPU reserved per copy, and that's the amount of memory that we're reserving in terms of each copy as well. And that's, once again, some math that you might have to do on your own. Once this is deployed, right, you can invoke it pretty simply. You can invoke the endpoint with the endpoint name, and then you have a header. Sorry, I did not mean to push that there. You have a target header right here specifying the component you're working with. In this case, we just have 1 component, which is our Quen model that we created. You can pass in your payload, and then you can run sample inference on this, right? You can imagine, right, as you scale this out, basically you might have multiple components. That's why you have this target header to kind of identify it. Very similar to multi-model endpoints that we talked about earlier, but the actual application and usage of it is very, very different, right? So that at a high level is mainly what I wanted to cover. This was the LMI v16 container. I hope it was a helpful overview. Make sure, by the way, to delete all these resources. You don't want them up and running, especially on their GPUs. But yeah, the v16 container, once again, it's staying up to date with vLLM basically, and it comes with those latest and greatest kind of serving files or serving properties that you can kind of adjust and play with. I think I'll make another video, honestly, in terms of what each of those mean and what you can do for LLM inference optimization and what's the latest we're seeing in the space there. But it's a great way of getting started, just even enabling that async engine mode. I recommend you take your LLM, your use case, take it for a spin, see how the performance is. Feel free to let me know if you run into any problems, as always, in the comments or LinkedIn or Twitter, wherever it is you want to connect. But yeah, hope it was a useful introduction. Thank you as always, and if you enjoyed the video, feel free to leave a like and subscribe. I'll be back with much, much more in this space. Lots of exciting stuff in this field as always, so appreciate it, and I'll keep you guys up to date.